the equation of a line that you know is slope y-intercept. That's a form some of you know. Y equals mx plus b. For those of you that use that form, you're really going to like another form for the equation for a line, which is the point slope format. You will love using it here shortly. I bet before you get done with this lesson, a lot of you are going to convert to the point slope form. The point slope form, or an equation of a line, looks like this. Y minus y sub 1, you may have it on note cards already because last year, is equal to m times x minus x sub 1, where m is what? Slope. And what is x sub 1, y sub 1?
1 point.
It's your point. So if I highlight where numbers should be when you write your equations in the slope y-intercept format, numbers are going to be in those highlighted positions. M is your slope, B is your y-intercept. If I look at the point slope format, M is your slope, you will have a number there. And you will also replace y sub 1 and x sub 1 with numbers, which is going to be a point value you have, whatever the point may be. Now there's other forms, but right now that's just the next thing that they talk about in the book. It says the point slope form. Our goal is to write an equation for a line in figure 20. Note that this line passes through 2, 3, and it also passes through the point 7, 5. That can lead you to yet another form for an equation for a line, which is, I think they refer to it as the double point or 2-point equation for a line. Not quite for sure. 2 points format for an equation for a line. It's going to be y minus y sub 1 is equal to, now here's the only difference, is that I don't know the slope because I have 2 points, but I can find the slope because it's y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Where you have the coordinate point x sub 1, y sub 1. This is getting slow. And x sub 2, y sub 2 are points. Those happen to be points. So where will numbers occur? Numbers will occur, and keep in mind this could be y sub 2 minus y sub 1. I don't care which way you subtract your values here, but these are going to be points which are going to eventually narrow down to the slope which you see up here. And that equation, that's the only difference, is you got to find that slope first from your 2 points. And then you're going to place a number in place of the x sub 1 and the y sub 1. This is when you don't know the slope. But what I do is I don't put it into this big equation. Just off to the side, when I encounter 2 points, when I find 2 points, I go off to the side and I find this value, I find that slope first. I find this first, and then I just stick that in for a number right there, which gets you back into that right there. It gets cumbersome to take this and start putting in all those numbers right there in that fractional format. It's easier if you just calculate it off to the side first. My personal opinion or preference is to do that. So that example that they, or what they're talking about in your book, they give you this graph and they plot 2 points for you. They plot the point 2, 3. I'm just roughly going to sketch these down here so we get the general idea. And then they also give you this point 7, 5 out here. And they want the equation for the line that goes through those 2 points. How do we find the equation for the line between those 2 points? Well, they also give you this other point here they call as xy. And they talk about trying to find your slope. We could, here's what happens if you use that 2-point or that double point equation of a line. It looks like this. Pick a point, doesn't matter which point. I don't care. Pick a point. 2, 3, because they're smaller numbers. That's what I like. So what's the y value of that point? 3 is equal to, now I got to pick that point, and it's the change in y over the change in x times x minus this x value here has to correspond with the y value right there of the 3. So that's going to be a 2. So there you get kind of a complicated equation where before we could come off to the side and we could just find the slope, which is the change in y over the change in x. So I'm going to take one y value and subtract the other y value from it over the first x value minus the second x value, and your slope ends up being -2 over -5, which is a positive 2/5. If you have that, then you could eliminate this complicated part right there. And you could say, what equation for this line is y minus 3 is equal to 2/5 times the quantity x minus 2. There's an answer. That's an equation for a line that I can create right there. But is there another answer you could have? Well, sure. What if I pick the other point? Can I pick the other point? Yes, you can. It doesn't say you have to pick the point to the left. It doesn't say you have to pick the point to the right. It doesn't say any particular point. If I pick the other point, it's going to be y minus what? 5 equals, my slope's still going to be 2/5 times x minus what? 7. This is also an acceptable answer for the equation for the line. Those are the exact same line. They may not look the same, but they're exact same line. That equation right there represents that line right there. Now I could do that y equals mx plus b thing that some of you like. From clear back in Algebra 2, we worked with generating equations for lines. And we said y is equal to mx plus b. And how did you come up with an equation for the line? Oh, you used this format, except for Cassidy. And you did, Cassidy's done. That's as far as Cassidy has to go, is the blue or the red equation. That's as far as she has to go. She's done. And you guys are over here doing this. Okay, I still have to do this step right there, right? I'm still going to have to find the slope. So after I've done this step, which is finding the slope, then you do this. Pick a point. Does it matter which point? No. What is the y value of the point? 3. What's your slope? 2/5. What's your x value? 2 plus b. Does this ring a bell? This is what a lot of you were doing. So then you get 3 is equal to 4/5 plus b. And you're like, wow, that doesn't even look like that blue equation or that red equation. So then we continue working. And I'm going to subtract 4/5. And what is 3 minus 4/5? 2 and 1/5 is equal to b, which is the same thing as 11/5. So then what's your equation for your line? Now that is an acceptable equation for the line, which is that line right there. Same line. Do I have to put it in slope y-intercept format? No. Let's go with that first equation. Y minus 3 is equal to, that was really, my board's really slow today. Like I said, I need to get rid of those videos. It's taking up a lot of space. 2/5 times x minus 2. Okay, I take that equation. I want it in a different format. I want to see if this is the same thing as that down there. How do I see if they're equivalent? How do I know the blue is the same thing as the green and the answer is correct? That's why I have to check these. I can't have some nice teacher's aide or just a para come in and check papers for me because they're going to count it wrong. There's 3 different answers I've given you so far that are correct. I take this. How could I rearrange that? Yes, you distribute. So I'm going to distribute, which says, can you see that green back there? Y minus 3 is equal to 2/5 x. And if I distribute, what is 2/5 times 2? Negative 4/5. And then we're going to add 3, just a little slow. So that says y is equal to 2/5 x. And what is negative 4/5 plus 3? 11/5. Are they the exact same thing? Yes, they're just in a different format. Be careful of what they ask you for. If you flip to your homework assignment, you will notice that 7 through 12, find an equation for the indicated line. Does it say what format you have to put it in? What would I do? Whichever is easiest for you. But look at all this calculation I had to do here in green. What all did you have to know for blue? All I had to do is find the slope. Did I have to find the slope for the green? Yes. All you have to do for the blue or red is put the slope in and put the point in, and you're done. Right there's your answer. You're done. Like I said, I don't care which way you do it, but I'm guessing by the end of this, you might become friends of the blue and the red method. Lucky you. What about 13 through 16? Now it says write your answer in the form of ax plus by equals c. Oops. Let me back up. I just got to wait here. Okay, I did hit it, I do believe. Yes, I did. All right, here's another form that they are looking at. They want it in the form of ax plus by equals c. Well, what's that mean? A, B, and C are going to be integers. They don't want them to be fractions. You could go into a double intercept form for an equation for a line. You could go into the general form. You could go into a standard form. Here they're wanting you to put the x and the y's on the same side and put your constant on the other. So if you talk about y equals mx plus b, what do they want me to do? They want me to take this mx and move it over to the other side. So I would have, they usually want this coefficient of m to be positive. Oops, b in this case. That's what they're looking for. Put the x and the y's on the same side and have your constant on the other side. Not as easy to determine though what the graph is going to look like. If I come back over here and you say, oh, well, this is not as easy to graph when it's in the point slope format. Yeah, it is. It's just as easy. Does it matter which point I start at here? I'm starting at the point 2, 3, and I'm going to count my slope. I'm going to go up 2 over 5. I'm going to go up 2 and over 5. That's just one right there. X is not working for it. I should back up. I'm going to go up 2 and over 5 to get to that actual point. Sorry. We don't have a space in between them like we did the last example. Because I go from 3 to 5. So it's up 2 over 5. I don't care where I start. I could, if I knew this point right here, I could find another point by going up 2 and over 5. So if I wanted to graph in this blue equation right here, all I have to do is start at the point. What's your point? The x value is, it's the opposite of what occurs there. So my x value is 2, my y value of my point is 3. So what you do is you come over here, you find the 0.23, and from there, you go up 2/5, use your slope, and there's your graph. It doesn't have to be the y-intercept, which is what you're finding in the green. So it's just as easy to graph those. You look at, and we will get to some examples with the ax plus by equals c. You will notice that they want it in ax plus by equals c, for example, 7 for problems 17 through 24 as well. 25 through 28, they want it in the slope y-intercept format. So a lot of this, you've worked with lines before. You're just going to work with putting them in different formats. That's what they want you to work with. So we'll get back to some of this tomorrow. We're going to go ahead and stop. The volleyball girls will be going here shortly.